Hi guys, this is the answer key for the practice quiz 4C through 4E. So our first set of problems here says to tell whether each number is prime, composite, or neither. So remember that prime numbers only have themselves and 1 as factors. Composite numbers have a minimum of 3 factors, and then the number 1 is neither because it only has 1 factor. So we can, right off the bat, I'm just going to put an N there because we know that 1 is neither prime nor composite. Well, for the number 12, it's even and it's bigger than 2. So I know that that has to be composite because it at least has 1, 12, and 2 as factors. That one's composite. For the number 19, the only factors of 19 are 1 and 19, so that one's prime. For 33, I know that that's divisible by 11 at least, and so 1 in itself. Of course, it's divisible by 3 as well, so this one's composite. And then 23 can only be divided evenly by 1 in itself, so that's prime. Listing all the factors of 18, here's how I like to do this. So I know that, of course, 1 and 18 are factors of 18. And then I just start moving up the number line. So I tried 1, now I'm going to try 2. Is 2 a factor of 18? It is. 2 and 9 are factors of 18. 2 times 9 is 18. I move up to 3. Is 3 a factor of 18? It is. 3 times 6. And then I just keep moving up this number line until I meet this number. So I go up to 4. 4 doesn't divide into 18. Go up to 5. 5 doesn't divide into 18. And I'm already got 6 there, so I know I'm done. And so the factors of 18 are 1, 2, 3, 6, 9, and 18. All right. Next problem says to list 4 multiples of 7. The way I like to do this is I just start off with 7 times 1 and work my way up. So 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. And of course we can keep going with multiples because we can list an infinite number of multiples. All right, our next problem says to find the greatest common factor. Get my work out of the way here. So to find the greatest common factor, I can do that in one of 2 ways. I can use the ladder method or I can use the prime factorization method. So ladder method, first of all, I take 14 and 56 and I make a step or a rung of a ladder. And then I choose the smallest prime number that will divide into both of those. Well, they're both even, so I know that 2 will work. 2 divides into 14 7 times, and 2 divides into 56 28 times. Both of these can be divided by 7, and so I do that. 1 and 7 divides into 28 4 times. For greatest common factor then, I take these 2 numbers along the side numbers only, and multiply them together. And so the greatest common factor for 14 and 56 is 14. Also a little trick is if one of the numbers divides evenly into the other number, then you know that the greatest common factor is the smaller of the 2 numbers. All right, now if you're going to use the prime factorization method, then what you would do is you would find the prime factorization of both of these numbers. And so we're going to find the prime factorization of 14 first of all. And so the prime factorization of 14 looks like this. We just make a tree and start listing factor pairs for this. So I know that 7 times 2 makes 14. Those are factors of 14. Both of those are prime, and so I'm done with those branches of my tree. And then the prime factorization for 56, I know that 2 can divide into 56, and I know that that goes in 28 times. 2 is prime, so I circle that. I know that 2 divides into 28 14 times, so that branch of the tree is prime, I circle that. And then 2 times 7 is 14, and those are both prime, so I circle those. Now, to find the greatest common factor from the factor trees is that you pick up every factor that's common to both trees. So both trees have a 7, I pick up that factor, and both trees have a 2, I pick up that factor. And my answer then, of course, would be 14. So 2 different ways to do these. Either way is appropriate, whichever you like. All right, 12 and 33 using the ladder method, again looking for greatest common factor. And the greatest common factor of 12 and 33, first using the ladder method, 12 and 33, can't both divide by 2, but then the next prime up is 3, and both of those are divisible by 3. 3 divides into 12 4 times, and it divides into 33 11 times. I can't divide the same number into both 4 and 11, so I know that my greatest common factor then here is 3. Using the factor trees, we've got 12 factors to 4 times 3. 3 is prime, and then 4 is 2 times 2, and both of those 2's are prime, so we're done with our tree there. And then 33 factors into 3 times 11, and both of those are prime, so we're done with that branch. All right, and again, we want to pick up everything that is, every factor that's in both trees, and you can see that 3 is there, and so my greatest common factor then is 3. All right, 44 and 77, using the ladder method, 44, 77. Of course, 11 divides into both of those, and now these don't have any common factors, so we know that 11 is our greatest common factor. Using the factor trees, 44 is 4 times 11, and then 2 times 2. That's our prime factorization of 44, 2 times 2 times 11. And 77 is 7 times 11. And so those are both prime. So the prime factorization of 77 is 7 times 11. You can see that 11 is common to both factor trees, and so 11 is our greatest common factor. All right, moving on to least common multiple. Least common multiple is the smallest number that both numbers that we have can divide into. So 12 and 10 would both be able to divide into its smallest common multiple. All right, using the ladder tree, 12 and 10, 2 divides into 12 6 times, 2 divides into 10 5 times. There are no common factors for 6 and 5, and so now for this, instead of just picking up, for least common multiple, instead of just picking up the 2 on the side, we're going to make an L and pick up all the numbers. And so we would say 2 times 6 times 5. And if we do 2 times 6, we get 12, and 12 times 5 is 60. So let's look at that using the factor trees. The prime factorization of 12, we'll do 6 times 2. 2 is prime. And then 6 is 3 times 2, and those are prime. So we're done with that factor tree. And 10 is 5 times 2, and those are both prime, so we're done with that factor tree. Now, for this one, we have to pick up everything that is common to both of them, every factor that occurs as many times as it occurs. So we've got 3 times 2 times 2 over here, and we've got 5 times 2 over here. So a 2 occurs the maximum of 2 times. So we pick that up twice, not 3 times, twice. It's once and then twice. And then we pick up the 3 and the 5. Okay? So we've picked up 1 2, can get rid of that. Picked up the second 2, can get rid of that. Picked up the 5, can get rid of that, and picked up the 3. So we've got all of the factors that we need. And when we multiply these together, we get 2 times 2 is 4, times 3 is 12, times 5 is 60. Okay, 6 and 5. So 6 and 5 don't have any common factors, and so in order to find the least common multiple of 6 and 5, you just multiply 6 times 5, which would give you 30. If you want to look at the prime factorization, we have 3 times 2 for 6, and then for 5, we have 5 times 1. And again, we want to pick up every factor that's represented. So this is 3 times 2, and this is 5 times 1. 3 appears once. 2 appears once. 5 appears once. And of course, the 1 appears once, but multiplying by 1 is not going to change our number at all. So 3 times 2 is 6, times 5 is 30. All right, so same idea here. 7 and 9 don't have any common factors at all. So the least common multiple, the smallest number that both 7 and 9 will go into, is just 7 times 9, or 63. All righty, let's look at some word problems now on the back side of this and see how we can use these factor trees and these ladders to solve some of our problems. So the first one says, A package of hot dogs contains 10 hot dogs. A package of buns contains 8 buns. What is the least number of buns and hot dogs you must purchase so you don't have leftover hot dogs or leftover buns? So again, we have this clue word here, least number we need. So least number, least common multiple. This is telling us that we're going to do least common multiple. All right, so least common multiple for 10 and 8 using the ladder method. 2 is the smallest prime that divides into both of those, 5 and 4. And no common factors between 2 and 5. For least common multiple, we make our L and pick up all the numbers on the outside of the ladder. And so we have 2 times 5 times 4. 2 times 5 is 10, times 4 is 40. So 40 hot dogs and 40 buns. All right, let's look at that using the prime factorization method. So the prime factorization of 10, breaking it down into its primes, is 5 times 2. And the prime factorization of 8 is 4 times 2. 2 is prime, but 4 is not, so we've got to keep going on that one. 2. All right, and then least common multiple, we want to pick up the factor as many times as it occurs. And so 2 occurs once, 2 occurs twice, 2 occurs 3 times, and 5. And so 2 times 2 is 4, times 2 is 8, and then 8 times 5 is 40. And so we get our 40 hot dog buns and hot dogs. All right, next one. A party store is making balloon bouquets for a Halloween party. Every bouquet will be identical. The store will use 24 orange, 36 black, and 12 purple balloons altogether. What is the greatest number of balloon bouquets the store will put together? So greatest, there's our clue. We're looking for greatest common factor. All righty, using the ladder method. 24, 36, 12. I see that I can divide all of those by 2. 24 divided by 2 is 12. 36 divided by 2 is 18. 12 divided by 2 is 6. I see that they can all be divided by 2 again. 12 divided by 2 is 6. 18 divided by 2 is 9. 6 divided by 2 is 3. And I see that all of those can be divided by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. 3 divided by 3 is 1. Now this is greatest common factor, so we only pick up the factors along the edge. And so we're going to do 2 times 2 times 3 is our greatest common factor. So 2 times 2 is 4, times 3 is 12, 12 bouquets. All right, prime factorization method. Prime factorization of 24. We're going to do 4 times 6. Neither is prime, so we've got to keep going on both of those. 4 is 2 times 2. Those are both prime. Circle them. And then 6 is 3 times 2. Both prime. Circle them. All righty. And then we've got, so the prime factorization of 24 is 2 times 2 times 2 times 3, or 2 cubed times 3. Okay, 36. Break that down into 6 times 6. And neither of those are prime, so we have to keep going on that track. And we break those down into 3 times 2. And finally, 12. Prime factorization, we can do 4 times 3. 3 is prime, and 2 times 2, both of the 2's are prime. So again, we want all of the factors that are common to both. And so we see that we've got a 2, a 2, a 2. We have 2 there. Then I've got this 2, and this 2, a second 2 there. And then I have a third 2 here, but I don't have it in these others. So for greatest common factor, we don't use that 2. I've got a 3, and a 3 in all of them. Now I've got extra 3's here, but not in all of them. So we only use that once because it only occurs once in the 12 here, and also in the 24. All right, and then we're 2 times 2 is 4, times 3 is 12, 12 bouquets. Okay, a radio station is having a promotion in which every 12th caller receives a free concert ticket and every 15th caller receives a limo ride. Which caller will be the first, kind of reminds me of the word least, to win both? So first, again, comparable to the word least, right? So we're looking for least common multiple here, okay? Alrighty, so we want the least common multiple of 12 and 15. Ladder method, I see that 12 and 15 are both divisible by 3. 3 divides into 12 4 times, 3 divides into 15 5 times. No other common factors between 4 and 5 except for 1. This is least common multiple, so I need to pick up all of the numbers on the outside of the ladder. And so it's 3 times 4 times 5. 4 times 5 is 20, times 3 is 60, so the 60th caller is going to win our concert tickets. All right, let's look at that using the prime factorization method then. Prime factorization of 12 is 4 times 3, and then 4 is 2 times 2. And then prime factorization of 15 is 3 times 5. And so we want to pick up every number that that occurs as often as it occurs. So there's 1, 2 here, but we've got to pick that up. There's another 2 here, so we pick that up. There's a 3, so we pick that up, and then there's a 5, so we pick that up. All right. So we've got 2 times 2 is 4, times 3 is 12, and 12 times 5 would give me my 60. So we're good. All right, last one. People, here we go. Mai has 15 oranges, 9 peaches, and 18 pears. She wants to put all the fruit into baskets, with each basket having the same number of pieces of fruit in it. Without mixing the fruit, which is the greatest number of pieces of fruit Mai can put into each basket? We're looking at greatest here. Alrighty, so we've got 15, 9, and 18. I'm sorry, this is GCF. I didn't finish my thought there, did I? And divide these by 3. 3 goes into 15 5 times. 3 goes into 9 3 times. 3 goes into 18 6 times. No other common factors down here that would go into all 3 of those. And so for greatest common factor, we only pick up what's on the edge there. And so she can make put 3 pieces of fruit in each basket. Okay, looking at the prime factorization method. 15's prime factor breakdown is 3 times 5. Those are both prime. 9 breaks down into 3 times 3, both prime. And 18 breaks down into 6 times 3. 3 is prime, 6 is not. 3 times 2, those are prime, so we're done there. Alrighty, and then we pick up the factor that is common to all of them, and 3 is the only one that occurs in all of them. And so there's our 3 pieces. Alrighty, guys, if you are a little confused on anything, go back and watch the video again, ask questions when you come to class, and we'll be taking a quiz over this real soon.